Hello students, myself Manuj from Scholars Forum. Again, I'm welcoming you all to this homemade video series of class 11th and class 12 topics. In the previous video of liquid solution, we were discussing about colligative property. The link to the video you can find in the description. So in the previous video, we discussed about relative lowering of vapor pressure. How lowering in vapor pressure occurs when we dissolve non-volatile solute in volatile solvent. Okay, now today we are going to start a second colligative property which is called elevation in boiling point. We denote it by delta Tb. Okay, so before understanding what is the meaning of elevation in boiling point, let's understand what is boiling point. Okay, so what is boiling point? For any liquid, it is the temperature at which its vapor pressure becomes equals to atmospheric pressure. Are you getting this thing? If I start heating vapor, if I start heating liquid, so what will happen? Its vapor pressure will increase. Okay. So once its vapor pressure start increasing, so after a certain time, what will happen? Its total vapor pressure will become equals to what? External pressure. If this thing happens means in vapor pressure of liquid by heating, somehow it becomes equals to atmospheric pressure. So what will happen? What will happen? Your liquid will simply boil. So that temperature will be called boiling point. Means अगर आप अपने लिक्विड के वेपर प्रेशर को एक्सटर्नल प्रेशर के बराबर इंक्रीज कर देते हो तो जिस टेम्परेचर पे भी ये कहानी होती है इस टेम्परेचर को हम क्या नाम देते हैं? बॉइलिंग पॉइंट. क्लियर बात? बॉइलिंग पॉइंट डेफिनेशन. ओके, नाउ लेट मी आस्क यू वेरी सिंपल क्वेश्चन. If I go to higher altitudes, let's say I went to Mount Everest. So if I went to Mount Everest peak, so tell me, there liquid will be boiled at high temperature or liquid will be boiled at low temperature? Think about this and then answer. So what will you answer? You should answer that as we go up, as we go to the higher altitude, tell me atmospheric pressure increases or atmospheric pressure decreases? Atmospheric pressure decreases. Are you getting this thing? So once you move to the higher altitude, atmospheric pressure decreases. So in order to become, let's say your atmospheric pressure, it is decreasing. Are you getting this thing? Atmospheric pressure decreases means you will require more heating or less heating. You will require less heating for boiling. Why we will require less heating? Because boiling point is what? Boiling point is the temperature when vapor pressure becomes equal to external pressure. You are saying that external pressure is decreasing. So if external pressure is decreasing, so we need less vapor pressure now for boiling. That means we require less heating. So you must have read this question somewhere. You must have heard about this. Ki at higher altitude, food cooks at relatively for a longer time. Regarding this thing means आप अगर मान लो हायर एल्टीट्यूड पे दाल को पकाना चाहते हो तो इट रिक्वायर्स मोर टाइम in order to cook as compared to your ground level. Regarding this thing, you must have heard about this. Why? Because at higher temperature, higher altitude, vapor pressure is low, atmospheric pressure is low. When atmospheric pressure is low, so our water boils too quickly. Our water boils too quickly without processing our food. That is why they say that in higher altitude we need pressure cooker. Definitely we need pressure cooker, or we need longer heating in order to cook the food. Are you getting this thing? So I hope boiling point is clear to us. Now what is the meant by elevation in boiling point? Let's take a scenario where I have a container in which I have liquid. Okay, here I have liquid. Let's say this time liquid is pure. Now let's take another container. So if I take another container here, and here I am having solution. Solution means you will have solute as well as solvent. Okay, you will have solute as well as solvent. Now think. Here some vapors will be present. Here also some vapor will be present. Okay. Now you answer me. Here vapor pressure is P1 and here vapor pressure is P2. So who will be bigger, P1 or P2? What you will answer? You will answer P1 will be greater than P2 because upon dissolution of solute, vapor pressure decreases. Up to here we have already studied. Okay. Now let's say atmospheric pressure is 1 atm. Let's say atmospheric pressure is 1 atm and they both, this P1 and P2, they both are less than 1. Atmospheric pressure से दोनों ही कम है. So now you start heating. Now you start heating here and you start heating here. Okay. So tell me, P1 will increase or decrease? P1 will increase. P2 will decrease or increase? P2 will also increase because we are heating now. So upon heating, vapor pressure increases. Use your logic and tell me who will acquire this 1 atm earliest? Who will acquire vapor pressure 1 atm earliest? Means whether it will be container number 1 or container number 2. You will say definitely it will be container number 1 because already वहाँ vapor pressure ज़्यादा है. Since vapor pressure is already more here, so you require here less heating and you require here more heating. So let's say here you require heating up to TB. Here you require heating up to TB. B stands for boiling. So here you will require heating till TB dash. Are you getting this thing? Here you will require heating till TB dash. So definitely TB dash will be greater than TB. 110% TB dash will be greater than TB. Okay? मतलब यहाँ पर कम टेम्परेचर, कमी हीटिंग में तुम्हारा 1 atm अचीव हो जाएगा. P1 की वैल्यू 1 atm जल्दी पहुंच जाएगी. यहाँ पर P2 की वैल्यू 1 atm पहुंचने में टाइम लगेगा. तो हम लोग बोलते हैं कि बॉइलिंग पॉइंट इस केस में बॉइलिंग पॉइंट जो कि TB डैश है वो ज्यादा आएगा. क्लियर है बात? गुड. Let's understand this phenomena in graphical manner. Okay. Now let's see. What I have drawn a graph. I am drawing a graph between vapor pressure and temperature. Okay. So let's say any temperature T. This is the vapor pressure of pure solvent. This is the vapor pressure for pure solvent. Now you tell me, if I increase the temperature, so vapor pressure will increase or vapor pressure will decrease? Vapor pressure will increase. Okay. How it will increase? Let's say. So it will keep increasing, and one time will come when this vapor pressure will become equal to what? 1 atm. So corresponding temperature here, this temperature, it will be called TB. TB means boiling point. Clear? Good. Now, very same temperature T. If I talk about solution, so solution will have more vapor pressure or solution will have less vapor pressure. So we will say solution will have low vapor pressure. So tell me, should I show my point for solution above this point or below this point? I should show below this point. पक्का नीचे दिखाना चाहिए. क्यों? क्योंकि उस टाइम पे vapor pressure, let's say it is PS or this is vapor pressure P naught. So who will be bigger? Of course P naught. So solution के लिए this point belongs to solution. This point belongs to solution. Now see, if I start heating solution, so vapor pressure will increase or vapor pressure will decrease? Vapor pressure will increase. So see, I am heating it. Vapor pressure will increase, and one time will come when vapor pressure will become equal to what? 1 atm. At that time, corresponding temperature will be called TB dash. TB dash is what? TB dash is new boiling point. Clear? I hope graphically you can understand who is bigger, TB or TB dash. TB dash is bigger than TB. So this gap is what? This gap is called delta TB, and this delta TB is simply called elevation in boiling point. You're getting this thing? This difference between new vapor pressure, new boiling point and old boiling point will be called delta TB. Let me write it here in symbolic form. So delta TB is nothing but TB new minus TB old. TB new minus TB old. And you tell me who is bigger, TB new is bigger or TB old is bigger? So of course TB dash is greater than TB. Physical interpretation is clear or not? If you want to boil solution of NaCl and if you want to boil pure water, who will require more heating? Who will require more heating? Aqueous solution of NaCl, it will require more heating because its vapor pressure is already low. Clear? Now let's derive a small formula for calculation of this delta TB. Now you better tell me, if I increase the amount of solute, so what will happen? Vapor pressure will increase or vapor pressure will decrease? You will say vapor pressure will decrease. Clear up to here? Okay. If you increase the amount of solute, so vapor pressure कम हो जाएगा. Vapor pressure कम हो जाएगा, ये बात clear है? Good. तो अब vapor pressure अगर कम हो जाएगा, so in order to make sure कि this vapor pressure reaches to 1 atm, it will require more heating or it will require less heating. बात clear है? Let me repeat one more time. कि आपका vapor pressure कम है, so you will require more heating in order to achieve 1 atm vapor pressure, or you will require less heating? You will require more heating. So once you require more heating, so can I say कि delta TB will be directly proportional to moles of solute. कि more solute you dissolve, keep dissolving the solute, so your vapor pressure will keep decreasing, and once you start heating, so you will get more boiling point or higher boiling point. You getting this thing? So since we are dealing with temperature here, so we have to take a concentration which does not depend upon temperature. Okay, so I hope you understand this. Molarity is affected by temperature. Are you getting this thing? But molality is unaffected. Molality is unaffected by temperature. So what we will do, delta TB, we will choose a unit which is temperature unaffected. So let's say delta TB is directly proportional to molality. We're getting this thing. So when we remove this proportionality sign, so we introduce a constant. So delta TB equals to Kb into M. Okay. So if M is equals to 1, means molality is 1. So I hope you understand that Kb will become equal to delta TB. Now from here you can define Kb. How will we define it? We will define it as Kb is elevation in boiling point of unimolar solution. What is Kb? Kb is nothing but elevation in boiling point of unimolar solution. Clear about? But if I take M equals to 1, so what is coming? Kb equals to how much? Delta TB. What is delta TB? Elevation in boiling point. So elevation in boiling point of unimolar solution is nothing but your Kb. Okay. What do we call this Kb? Kb is called molar elevation constant. Molar elevation constant, or it is also called ebullioscopic constant. See, ebullioscopic. Now this, like, try to pronounce it like this. It is called ebullioscopic, but in order to remember it, you just remember like this: ebullioscopic constant. Ebullioscopic constant, just like you are feeling vomiting something. So ebullioscopic constant, it is nothing but your Kb. Okay. Now this is the formula coming for us. If delta TB is equals to Kb into M. I hope this formula is clear to you, where M is molality, Kb is delta TB when M equals to 1. Kb is also called molar elevation constant or ebullioscopic constant. Now tell me one more thing. Can you tell me the unit of Kb? So unit of Kb will be what? Unit of, see, how will I write Kb? Kb will be equals to delta TB upon M. Now Delta TB, what is the unit for delta TB? Delta TB is change in temperature. So unit will be what? Kelvin or degree Celsius. By what is unit of molality? Molality unit is mole per kg. So unit of kb will be equals to Kelvin kg mole inverse. This is the unit for kb. Are you getting this thing? Good. Now some more important point let me write for you. There is a relation of kb with dB. kb is equals to r TB square upon 1000 LV. This is the formula for finding kb. This derivation for finding kb is not in our syllabus. Sometimes what happens, they don't give you the value of kb. They give you TB, they give you LV, and they ask you to find the kb or correlated questions. So what is TB here? TB is boiling point of liquid. What is LV? LV is latent heat of vaporization. Latent heat of vaporization. This is your LV. Okay, formula is clear. R TB square. What is R? R is universal gas constant. Okay, so you can easily find the kb from this formula. Now kb, I hope you understand this TB and LV, they are related to solvent only. They are related to solvent only. Means how do we define LV or kb? LV means latent heat of vaporization. Ki 1 gram of liquid, 1 gram of pure liquid, whatever amount of 1 gram of pure liquid, whatever heat is required to change its phase at boiling point from liquid to gas or gas to liquid is called latent heat of vaporization. मतलब 1 ग्राम लिक्विड को आप अगर बॉइलिंग पॉइंट पे लिक्विड से गैस में या गैस से लिक्विड में कन्वर्ट करते हो विदाउट चेंजिंग द टेम्परेचर, सो दैट हीट इज कॉल्ड लेटेंट हीट ऑफ वेपराइजेशन. ये डिफाइंड है प्योर सॉल्वेंट के लिए. बॉइलिंग पॉइंट किसके लिए डिफाइंड है? प्योर सॉल्वेंट के लिए. सो दैट मींस दिस kb डिपेंड्स ऑन सॉल्वेंट ओनली. Means whatever the solvent is, it will depend only on that only. Means it will never depend upon amount of solute present. It will never depend upon amount of solute present in your solution. Okay, so if I say water's kb is 0.52, for example, you should remember this value as well. Kb for water is equals to 0.52 Kelvin kg mole inverse. So if I say kb is 0.52, so it is 0.52 for all concentration possible. Means it is for 1 molar solution, it is also for 2 molar solution. It doesn't matter. Kb for water will be constant for any solution of water. Similarly, kb for alcohol will be constant for any solution of alcohol. Okay, I hope this thing is clear to us. Okay, so we have derived one small formula earlier. We derived this formula. Delta TB is equals to kb into m. We have already derived this. Now you tell me here what is m. Let me write here what is m. M is nothing but moles of solute upon weight of solvent in gram multiplied by 1000. I hope you know this formula. Molality, moles of solute upon weight in gram multiplied by 1000. What is W gram? It is weight of solvent present. Now you better tell me, is this formula 100% correct? What if our solute goes into the solution and it gets dissociated? मतलब मैं अगर एक पार्टिकल डालूं, हो सकता है वो अंदर जाकर के 2 पार्टिकल में टूट जाए, हो सकता है 3 में टूट जाए, हो सकता है 4 में टूट जाए. So what I will do then? There is small mistake in this. This will be called normal colligative property. This will be called normal colligative property. You have not considered here कि whether your solute is getting associated or dissociated. So let's say I don't care whether it is getting associated or dissociated. For effective number of moles, what I will do? I will multiply moles with I. I will multiply moles of solute with I. So here one more correction is required. Let's say for association or dissociation. So if association occurs or dissociation occurs, so in that case delta TB must be written as I into Kb into m. What I did here, I simply multiplied I in moles of solute, so I will get delta T equals to I Kb m. So for solving the questions, we will be applying this formula only. Okay, clear? Very good. Now, next colligative property is depression in freezing point. First, understand what is the meaning of depression in freezing point. But before that, let's understand what is freezing point. So, what is freezing point? Freezing point is the temperature at which vapor pressure of liquid and solid becomes same. Okay, or the temperature at which liquid and solid form of liquid are in equilibrium. Clear? Means the temperature at which vapor pressure of liquid and solid form is same, or the temperature at which both the liquid and solid form are in equilibrium. उस temperature को हम क्या नाम देते हैं? Boil freezing point. Clear? जब solid और liquid equilibrium में हो उस temperature को हम बोलते हैं freezing point. ठीक? Now see, means you have to achieve this equilibrium. Solid converting into liquid and liquid converting into solid. मतलब suppose at temperature T, 10 molecules of solid are converting into liquid, and if at very same temperature 10 molecules of liquid are converting into solid, so we say कि there is no net changes occurring, so T will be called freezing point. Freezing point is clear to us? Meaning of freezing point? Good. Now let's see what is observed if you add some amount of solute. If you add some amount of solute, so it is observed that freezing point is decreased. Okay, what happens when we add non-volatile solute? When we add solute in your liquid, so it is observed that freezing point is decreased. Clear? Now how it happens, let's understand. I hope you remember Lee-Chatelier principle. Lee-Chatelier principle, what it states? It states that if we put any equilibrium under any sort of stress, so what equilibrium does? Equilibrium somehow try to shift itself in the direction where effect of stress can be nullified. Okay? मतलब अगर आप किसी इक्विलिब्रियम पे कोई स्ट्रेस लगाते हो तो इक्विलिब्रियम हमेशा आपका उल्टा करता है, वो उस स्ट्रेस को खत्म करना चाहता है. Now what you are doing, you are adding solute in this equilibrium. You are adding solute in this equilibrium. So tell me, if you will add solute in equilibrium, so vapor pressure will decrease or vapor pressure will increase? You will say कि vapor pressure will decrease. Clear? Solute मिलाने से vapor pressure कम हो जाता है. Now, if vapor pressure is decreasing just because you are adding some solute, so what equilibrium will like to do? Equilibrium will like to increase vapor pressure, equilibrium will like to decrease vapor pressure. So भैया you are decreasing vapor pressure, so equilibrium will 100% like to increase the vapor pressure. Clear? Now how equilibrium will do so? If you want to increase vapor pressure, so you need more amount of pure solvent or less amount of pure solvent? You need more amount of pure solvent. So you know what will happen? In order to increase vapor pressure, this liquid will start forming. This liquid will start forming. Why? So that vapor pressure can be increased. Okay. Now, how will it start forming? How will it start forming? It will start forming when solid will start melting. Solid will start melting. So if solid will start melting, so liquid will start forming. If liquid will start forming, so vapor pressure, liquid of what? Liquid is pure solvent, so vapor pressure will increase. Are you getting this thing? So if you want to solidify this solution, so you will have to apply more cooling. More cooling will be required to freeze this. Why? Because this equilibrium has decided, nahi beta, I will increase liquid amount so that vapor pressure can be increased. But if you wish to get solid back, you will have to apply more cooling as compared to your normal freezing point. So let's say if water freezes at 0 degrees Celsius, but if you add some amount of NaCl in it, So now it will freeze at, let's say, -2 degrees Celsius or -4 degrees Celsius, depending upon what amount of solute you are dissolving. Okay, clear about? Okay, let me repeat one more time. इस इक्विलिब्रियम में व्हाट यू डिड, यू एडेड सोल्यूट ऐड करने से क्या हुआ, वेपर प्रेशर कम हो गया. तो वेपर प्रेशर कम होगा तो इक्विलिब्रियम क्या चाहेगा, वेपर प्रेशर बढ़ जाए. वेपर प्रेशर बढ़ाने के लिए लिक्विड क्या करेगा, ज्यादा फॉर्म होना चाहेगा. अब लिक्विड ज्यादा फॉर्म होगा, लिक्विड मतलब आपका प्योर सॉल्वेंट. सो प्योर सॉल्वेंट ज्यादा फॉर्म कैसे होगा, व्हेन सॉलिड विल मेल्ट. नाउ सॉलिड, इफ सॉलिड विल स्टार्ट मेल्टिंग, दैट मींस कि solid is start melting, that means you will no longer have solid in your system. Now when you will have no longer solid in your system, so in order to obtain solvent, in order to obtain solid, we will require more cooling. So here I am writing more cooling required. Are you getting this thing? Okay, I hope it is clear. Let's understand in another way. This is exactly as Lee-Chatelier principle, but you can understand this depression in freezing point phenomena by another method. Let's say this. Suppose if you have this container, okay, it is filled with liquid. Okay, what you did, you took a container, you added some amount of liquid here, so it will start vaporizing. You will get to see vapors everywhere. Now if you start freezing it, if you want to freeze it, so you will have to apply cooling. You will have to apply cooling. Now let's see what will happen. First, who will get freeze? See, you have to freeze this liquid plus these vapors. Remember, vapors are generated from liquid, so you have to freeze them as well. Okay, now let's see how it will happen. When you start cooling, so tell me, who will be freezed first, liquid or vapor? So definitely liquid will freeze first. So upper layer of liquid will be freezed. You can perform this experiment at your home also. You just take a bowl, add some amount of water, put it in freezer. So after some time, in the very beginning, upper layer of water is freezed. Upper layer of water is freezed. So in the same manner, your upper layer will be freezed. Then layer touching this upper layer will freeze again. Now it will again freeze. So a time will come when entire liquid form will be freeze. Now our motive is not just to freeze this liquid form, we have to freeze this water as well. Now that's what we call freezing. Now see, so when you go for freezing, so what will happen, these vapor, because of these random motion, they will try to collide. With this solid. So when molecule collide, they get cooled and they get freezed. Now I hope you understand, if you will have more vapors here, so top vapor will collide with bottom vapor. Top वाले vapor bottom वाले vapor से टकराएंगे, तो it will be like these vapor will be pressing these vapor molecule. Na? See, this vapor layer will press this bottom layer. Okay, go and collide with the solid form. So upper layer will try to push it towards solid. So it will help you in freezing. So now vapor will collide with solid phase and it will get freezed. Now if you take the case of solute is present in solution. Now you understand, here vapors will be very less. So again what will happen, top layer will be freezed, then this layer will be freezed, then this layer will be freezed, then this layer will be freezed, entire liquid will be freezed. But our motive is not only to freeze liquid but also to the vapors. Now these motion of these molecule will now be less random. Are you getting the same? Means this time, since there are very less vapor present, so upper layer will have low tendency to push this bottom layer towards solid. मतलब अब तुम्हारे पास वेपर्स कम है, तो अपर लेयर की नीचे वाली लेयर को नीचे की ओर पुश करने की टेंडेंसी क्या होगी, कम होगी. अच्छा, अगर ऊपर वाले लोग कम प्रेस कर रहे हैं नीचे वालों को कि जाओ बेटा सॉलिड से टकराओ और जाके सॉलिड बन जाओ, तो अब फ्रीजिंग होने में टाइम लगेगा. क्यों? क्योंकि तुम्हें अब ज्यादा कूलिंग करनी पड़ेगी. यहाँ पे you will require more cooling. Why? Because you don't have high upper layer of vapor which was pressing the bottom layer towards solid. So you will require more cooling so that they will they will keep losing their randomness, they will keep losing their motion, and finally they will fall in solid form. So you will require more cooling in this case. Okay, so I hope you understand that when we add pure liquid, when we add solute in the solvent, so its freezing point is decreased. Suppose this is your pure solvent. So if you start cooling it, its pressure will decrease. Here it is vapor pressure, here it is temperature. So its vapor pressure will decrease. But a time will come when it will start freezing. Now you tell me, solid has more vapor pressure or solid will have more tendency to vaporize, or liquid? Solid will have less tendency to vaporize, so its vapor pressure will be not just low but very low as compared to liquid. तो जैसे ही आपका liquid solid में convert होना start होगा, so its vapor pressure will not just simply reduce, it will highly reduce like this. You're getting the same. Here what is this? This is solid. This is liquid. What is this? This is solid. You're getting this? Good. Now, at whatever temperature this thing happens, we call this freezing point. This temperature may be liquid or solid form ka vapor pressure. Here what is this? At this point, we have solid as well as liquid. This point solid plus liquid, this point only solid, this point only liquid. Now, if this temperature, let's say T1, if I take my solution, so solution will have less vapor pressure like this. Here, okay, if you start cooling it, again its vapor pressure will decrease, it will decrease, and the moment when its vapor pressure will become equal to spray vapor pressure of solid, we will say this is our new freezing point, TF new, and this gap will be called delta TF. This gap will be called delta TF, or we call it depression in freezing point. Depression in freezing point. Okay, good. Now, just like we derived the formula in elevation of in freezing boiling point, similarly, this delta TF will also be directly proportional to molality. Just like we will remove this K, and what we will get? We will get delta TF equals to, this time KF. This time KF. KF is called molar depression constant. Why depression? Because freezing point is reduced. Depression constant, or it is also called cryoscopic constant. It is also called cryoscopic constant. Okay. Now, molar depression constant or cryoscopic constant, if you put m equals to 1, so you get delta TF equals to KF. So how will we define KF? KF will be defined as, it is depression in freezing point for 1 molar solution. Okay, just like we defined KB, similar manner we are defining KF. Okay, just like we had formula for TB, we have formula for KF also. KF equals to how much? It is R TF square upon 1000 L. Now this time it will be, remember, see here, there what we used? We use R TF upon 1000 LV. LV was latent heat of vaporization. This time we will use LF. What is LF? LF is latent heat of fusion. What is TF? TF is freezing point. Okay. Now, I hope you understand this formula is partly correct. Why? Because we are not considering the effect of dissociation of solute. So if I want to consider that dissociation or association as well, so delta TF will now become equals to I KF into M. I KF into M. What is I? I is Van Hoff factor. One more thing, delta TF will be, tell me who is bigger, new vapor, new freezing point is bigger or old freezing point is bigger? You can see the old freezing point is bigger than new freezing point. So delta TF will be written as TF old minus TF new. In delta TB we wrote TB old, TB new minus TB old, but here it will be opposite as delta TF old is greater than delta TF new. I hope this thing is clear to you. Good. Now, cryoscopic constant, I hope you are understanding this term. Just remember, just like your KF, KB was not depending upon type of solute. Similarly, KF also does not depend upon type of solute. Now, KF for water is equal to 1.86. Unit is exactly the same, Kelvin kg mole inverse. KF equals to 1.86 Kelvin kg for mole inverse. It is for water. So if you take any solution in which water is solvent, so KF will remain constant. Okay. Now next colligative property is osmotic pressure. Next colligative property is osmotic pressure. So before understanding osmotic pressure, let's understand what is osmosis. So what osmosis is, it is a process in which net flow of volatile solvent particles takes place from higher concentration with respect to solvent. मतलब solvent का concentration ज़्यादा होना चाहिए. From higher concentration of solvent to low concentration with respect to solvent through semi-permeable membrane. Semi-permeable membrane, we also call it SPM, is called osmosis. Okay, means we will have a membrane. We will have a membrane, let's say it is SPM. This side of SPM we have 1 molar NaCl. This side of a membrane we have 2 molar NaCl. Who is more concentrated? 2 MaCl is more 2 molar NaCl is more concentrated. But where concentration of solvent is more? Where concentration of solvent is more? 1 molar side or 2 molar side? It is on 1 molar side. Here we have more solvent. Here we have less solvent. So see what will happen. This arrow, these are showing flow of solvent particle. Arrows are showing flow of solvent particle. So where arrow length is more? Arrow length is more towards right. Although arrow length is more at right, it is very less at left side. Now means from here to here less solvent particles are moving, and from here to here more amount of solvent particles are moving. So net flow is occurring from left to right or right to left. You will say net power movement is taking place from left to right. So this net movement, net flow through SPM is called osmosis. Now what is SPM? SPM, it is a special membrane which allows passage of only volatile component. Means if you are volatile, so you can go through this SPM. If you are non-volatile, so this SPM will not allow you to go through. Okay. Some example of SPM are like, I hope you understand, animal bladder. Okay. Or you can say cell membranes. These are natural SPM. We can prepare some artificial SPM as well. Let's say copper ferrocyanide. Or parchment filter paper, they all are type of SPM which is artificially. Okay, so I hope it is clear. Now let's take a consider to this arrangement. What I have done here, I have placed the SPM. Okay, here is a container which has 1 molar NaCl left side. I have another container which has 2 molar NaCl on right side. These two are separated by this SPM. Now where net particle of solute will take place, net particle of solvent will take place from left to right. We have already discussed exactly the previous case. Now here vapor pressure is P1 and here vapor pressure is P2. So tell me, P1 is greater than P2 or P2 is greater than P1? कौन बड़ा होगा? P1 will be greater than P2. Okay. Now since P1 is greater than P2, so what will happen? Here pressure is more, here pressure is less. So movement happens from high pressure to low pressure or low pressure to high pressure. It happens from high pressure to low pressure. That means net movement of solvent will be from left to right. Now what will happen? When net movement of solvent particle will take place from left to right, so what will happen here? In this solution level will start rising. Solution level will start rising. So after some time you will find this no longer this height will be increasing. Means up to a certain limit only this water will rise in this jar. Are you getting this thing? It will not be like it will keep rising. No, it will not keep rising. Why? Because once water start gathering here, so I hope you understand. Let's say this height is h. So because of this h height, some extra pressure, let's say P dash, will be equals to h rho g. Additional pressure P dash will also start occurring at this P2 side. Okay, repeating one more time. क्या होगा? यहाँ से नेट सॉल्वेंट का फ्लो इधर होना स्टार्ट हो जाएगा. नेट सॉल्वेंट का फ्लो इधर, नेट फ्लो हियर, फ्रॉम राइट टू लेफ्ट, नेट फ्लो हियर, net flow here. It will keep happening. Water will keep rising here. After some time you will find that water has risen to h height. Water has risen to h height and there is no further rising of water. There is no further rising of water. It will be only and only because maybe both side pressure have become same. Maybe both side pressure have become same, means P1 is now become equals to P2. But how? By adding P dash on its side. Regarding this thing, this h height pressure, which is nothing but P dash, h rho g, it will act on right side. So now right side pressure will be P2 and P dash. Sum of these two must be equals to P1 so that no net flow of water will take place. No net flow of solvent will occur. Regarding this thing, no net flow of solvent will occur. Can I say this thing? If this thing happens, so no net flow of solvent particle takes place, that means osmosis is stopped. Osmosis is stopped. Regarding this thing, so once osmosis is stopped, so let me tell you one thing. Since osmosis is stopped, so what if we apply this pressure h rho g in the very beginning? Okay, what if before it's rising, if I apply this P dash pressure from external source in the very beginning? So what will happen? From the very beginning, P1 will be equal to what? P2 plus P dash. So will osmosis take place? No. No net flow of solvent will take place. So I will say कि this P dash, what is P dash? Let me define it. P dash is the pressure which requires to be applied on, tell me, where did I apply? Less concentrated side or more concentrated side? On more concentrated side. On more concentrated side. Remember, this concentration I have written with respect to solute. More pressure which requires to be applied on more concentrated side, with respect to solute, in order to stop osmosis. In order to stop osmosis. And the very same pressure we call it osmotic pressure. Are you getting this thing? The pressure which stops osmosis process, we call it osmotic pressure. मतलब अगर यहाँ pressure है let's say 5 atm, or here pressure is 10 atm, so pressure flow will take place from 10 atm to 5 atm. But somehow if I apply additional 5 atm here, so that here pressure also become 10, here also become 10, so this additional 5 atm pressure will be called osmotic pressure. Definition is clear for osmotic pressure? Good. Now remember, osmotic pressure will be denoted by pi. Osmotic pressure is always applied to the high concentrated side with respect to solute, or to low concentrated side with respect to solvent. Means wherever solvent is less, we apply osmotic pressure there. If you apply osmotic pressure, your osmosis process will surely stop. Okay. Now, I hope you understand this. This pi must be directly proportional to moles of solute. This pi must be directly proportional to moles of solute. Why? Let's see. Let me give you this example. Let's say here I have 1 molar solution and here I have 2 molar solution. Here vapor pressure will be P1, here vapor pressure will be P2. What is this? This is your SPN. Okay. Now, if I say here P1 equals to X plus P2. So what is X? X will be osmotic pressure. Now if you apply X pressure, or let's say it is osmotic pressure, but when you apply X pressure to this P2 side, your osmotic pressure will decrease, or your osmosis will stop. Now let's change this 2 to 3. Now let's change this 2 to 3 molar. So tell me, this P2, it will increase or P2 will decrease? P2 will definitely decrease. So if P2 will decrease, so in order to equate P1 with P2 now, you will require less osmotic pressure to be applied or more? You will require more osmotic pressure. Let's say big X. So as you keep increasing the concentration of solute here, if you keep increasing concentration of solute here, so this osmotic pressure will increase. So pi will be directly proportional to concentration of solute or inversely proportional? It will be directly proportional to concentration of solute. C stands for molarity. C stands for molarity, mole per liter. Are you getting this? Good. Now tell me, vapor pressure will be directly proportional to temperature, inversely it will be directly proportional. So pi is also directly proportional to T, means if you increase that temperature, so this required osmotic pressure will again become more. Okay, one more thing, if you combine this, so pi will be directly proportional to Ct, or pi will be equals to CRT, or you can find it pi equals to CST. I will use this. R and C same. R is what? Universal gas constant. What is T? T is absolute temperature. T is absolute temperature. So this is the formula for calculation of osmotic pressure. Osmotic pressure equals to CRT. Now, if I say solute is getting dissociated, or associated, I don't know. So I hope you understand the formula of C. C formula is N upon V, moles of solute upon volume in liter. So I will not write here N, I will write here I. So this formula will again be modified and it will be written as ICRT. This is the formula which we will use in numerical purpose. So calculation of pi will be simple, pi equals to ICRT. Okay, now let's understand some technical definition terms as well. First is exoosmosis. Osmosis are of two types, exo and endo. What is the meaning of exoosmosis? When net flow of solvent is outwards. Okay, when net flow of solvent is outwards, means when I am losing solvent, so I will say exoosmosis is going on. Means, example, shrinkage of resin in brine solution. What is resin? Resin kishmish. Shrinkage of resin in brine solution. Brine solution means aqueous NaCl. When you add resin, your kishmish, in your brine solution, so what happens? Resin gets shrink. Okay, so what happens? Whatever material is inside this resin, it gets flown out. So we say exoosmosis is going on. Now, endoosmosis, when net flow of solvent is inwards. Example, swelling of resin in water means when you add your resin in water, so it gets swelled. Means water comes inwards inside this resin, so we say endoosmosis is going on. मतलब अगर आप वो किशमिश को चीनी नमक के घोल में डाल दीजिए तो वो पिचक जाती है, और जब आप नमक वो किशमिश को अगर आप पानी में डाल दीजिए तो वो फूल जाती है. So one is called exo और one is called endo. Endo means net flow inwards, exo means net flow outwards. Okay, now let's consider two solutions. Let's say this is 1 molar and this is 2 molar. Pi 1 and pi 2 are osmotic pressure of these two. Pi 1 is the osmotic pressure of first and pi 2 is the osmotic pressure of 2. So who will be more, pi 1 or pi 2? Pi 2 will be greater than pi 1. Why? Because I hope you remember osmotic pressure is directly proportional to moles of solute. So here the mole concentration of solute is present. So pi 2 will be greater than pi 1. So technically we say its second solution is hypertonic. The solution which has higher osmotic pressure, we call it hypertonic. Okay. At the very same time, first solution will be called hypotonic. Means solution which has low osmotic pressure is called hypotonic solution. But suppose if pi 1 equals to pi 2, so we say its solution are isotonic. If two solutions have same osmotic pressure, so we say its solutions are isotonic in nature. Okay. For isotonic solution, pi 1 must be equals to pi 2. That means I1 C1 RT, remember pi equals to IC/RT. So I1 C1 RT should be equals to I2 C2 RT. For two different solutions, if they both want to be isotonic, so I1 C1 RT should be equals to I2 C2 RT. RT cancels, so what you got? I1 C1 equals to I2 C2. So this is the condition for isotonic solution. Condition for isotonic solution. So up in this video I discussed all the theoretical part of this colligative properties. So your task will be make proper notes of this colligative property, and in the next video I will be discussing about the problem based upon this colligative property. It is going to be very interesting. We will be solving the problems. I hope till now whatever I have taught you, you have understood it. If you got any doubt, ask me in the comment section. Okay, see you. Bye.